Hello, everyone. My name is Anand Gonuguntla. I'm the Vice President of Portfolio Solutions and Sales Engineering at Blue Planet. Today's topic is evolving the network and service operation centers to automate service lifecycle management. So, why is it important to evolve the good old knock and sock? Over the last 2 days, my colleagues spoke about various innovations in business, technology, and operations. In the next few slides, I'll share my thoughts on why knocks and socks need to evolve and how to go about it. The drivers for transformation are compelling. Carriers are facing immense challenge from over-the-top providers. Products and services are getting commoditized. The time it takes to introduce a new service and the life cycle of the service itself are reducing. 5G and IoT are presenting new set of challenges as well. Although these services are critical for carrier success in future, they introduce immense operational challenges. With 5G, the intelligent is moving to the edge, and with IoT, the device volume is increasing. Coupled to this, the virtualization is adding new set of challenges. Now, with virtualization comes with elasticity. What is made of a service is defined by time. A combination of hardware and software components distributed make up a service, and what it is changes over a period of time. Now, this is amazing for carriers because virtualization allows them to grow their networks without having to plan early on, but operationally, it's a whole set of new challenges. Moreover, all these services require a different level of service level agreements and compliance to those service level agreements. So, the methods used operationally in the current legacy environments are no longer scalable. Carriers have to look at new operational measures and new operational tools and processes to evolve with new trends. So the combination of business drivers is generating a ton of excitement for around operational transformation and knock and sock evolution. In today's hyper-competitive market, network providers globally must improve operational agility. They must monetize their networks, deliver highly differentiable customer experience. To do this, they must achieve more adaptive networks that are responsive on demand to customer expectations and ensure the most effective utilization of their network resources. Software-driven closed-loop automation presents the opportunity for network providers to address these challenges. There are growing demand from service providers globally to realize greater levels of closed-loop automation across all layers of the networks. Assurance plays a key role in closed-loop automation by allowing continuous optimization of service performance, quality, and availability on a proactive basis by resolving problems automatically before impacting the service and customer experience. So, what does knock and sock evolution look like? To some extent, it depends on the environment and the stage at which the carrier is at. On one end, it's totally manual and reactive. On the other end, it's totally adaptive, and that's the ultimate goal. Our vision at Blue Planet is to transition our customers through the transformation journey to become an adaptive knock and sock environment. So let's take a deeper dive at a reactive knock. What defines a reactive and responsive knock? Now, a customer finds a problem ahead of the knock, and that is really a fundamental issue in these environments. Now, most of you are familiar with the network operation centers and service operation centers. It's not very unusual for these NOCs to have multiple management systems, multiple OSS systems, whether it's inventory or assurance, or even multiple tools for fault and performance management. The issue, however, is a typical NOC, let's say take a small to medium NOC, have to process anywhere between about 100,000 to 500,000 messages a day, and they're in a somewhat larger size NOC has to handle several millions of events a day. A good portion of that is noise. Now, to get to an actionable data, there has to be noise reduction. The big problem with these reactive and responsive NOCs is not having those tools to reduce the noise. So I've been in many environments where there is a problem on the network which precipitates several thousands of noise alarms, and knock never gets to the bottom of the actionable events before the customer calls in, and that sets the chaos. Now, this is not good. It's very frustrating, very time consuming for the knock. The productivity tends to low. Customer is watching the behavior of the customer and the loss of service all this time. So it results in a very low MTTR, the long MTTR, and a poor customer experience. And of course, all the SLAs are impacted. Now, going into a proactive knock. Proactive knock is an improvement. These are typically the same systems. However, there are good noise reduction technologies. The algorithms allow customer to triage a handful of actionable events in real time. So instead of having to deal with a million messages, they have to deal with maybe 100 actionable events. Nevertheless, those actionable events need to be translated into customer impact, which means there is a whole bunch of manual correlation that goes from service assurance to inventory before the knock arrive at a customer impact. Now, this is a big improvement from a reactive and responsive knock, but it's not the end of it. There is some level of automation, some level of process. However, this is not the end state where carriers need to be. This method might work for the legacy environment, but looking at the scale of future networks, this is just not practical. Now, what's the limitation in these environments? Siloed operations. Now, most NOCs have to deal with three different diverse systems: inventory, orchestration, assurance. Inventory provides source of truth of the network, what services are available. Orchestration allows to provision or deprovision a service or adjust a service. Assurance provides the ability to manage and maintain the quality of that service to the customer. When these three systems are designed, they are designed independently, in some extent, actually, by different departments. The data models tend to be very diverse. There is very limited data that gets communicated between these systems. So there is no context for what goes between these systems. And a lot of that has to come from the manual intervention or the knowledge of the NOC and SOC community. However, this is extremely manual, result in long time to resolve customer issues, and more importantly, to communicate with the customer on what's going on. So what needs to be done going forward? To really realize a self-healing network, these systems need to be coupled. Unified inventory or federated inventory is a single source of truth that's real time, which maintains service logical and physical asset inventory. Orchestration coupled with assurance creates the interlink. So there is a service context. For example, when a service is created, it flows through into assurance system, and there's a context of what's a logical service and how it's tied to network resources. Similarly, as the time progresses, assurance system can measure how the service is performing and correlate individual network component failures to a service, thus taking actions when the thresholds are reached to go modify the orchestration service. So keep in mind, most of the services don't fail abruptly. They go through a progression of good to bad to ugly. And it's our job to catch and define what bad is and take measures before it gets ugly. Thus, customer never experiences an outage. And this is the ultimate answer for dynamic self-healing of this network. And this defines the closed loop automation. This is truly a next phase of development for NOC and SOC evolution, and this is doable very much today. There are many examples that can be solved with this method. Take an example of a bandwidth service. If you sold a service to your customer and the service is reaching a 90% utilization, you don't need to wait before customer calls you. You can take a action and reach out to the customer and maybe possibly upsell the service. If you take a dynamically rerouting a network, you could do that. You could take about examples of hosted applications. If you want to increase the capacity of the VM or usage level of the VM, you could change that. Now, key here is understanding the pattern that defines the threshold and defining a policy which can be acted upon real-time data. Now, take the step further. How about having a network that understands the behaviors, creates signatures and patterns? Artificial intelligence and machine learning are great tools to do that. These technologies are designed to identify patterns. Now, these are the patterns that could create a signature for a failure. Now, couple this with the policy management that we defined in the previous slide. Now you have a very powerful tool. And the networks can learn what patterns are problems and apply policies before they affect the customers. So the future mode of operation is completely self-healing, self-optimizing networks, intelligent automation, high staff productivity, and business growth. Now, this is obviously required to not only address the SLA compliance, but also bring all the operational savings the carriers are looking for looking forward. So in summary, the business is changing fast, networks are evolving, the systems and practices that are in place today and in the past are no longer scalable. Now, obviously, these systems need to be evolving and interlinked, and intelligent automation is the only answer for this. Blue Planet is here to help you through this journey. As I conclude my presentation, I want to leave you with two thoughts. One, what does digital transformation mean to your organization? Did you define one? Two, and this is a more important one, where would your organization be in 3 to 5 years if you don't embark on a transformation journey? Thank you.
Hello, my name is Dave Swanson, and I'm a solution architect with Blue Planet. Today, I'm going to be giving a quick walkthrough of our Network Health Predictor module, which is part of our Unified Assurance and Analytics platform. NHP uses algorithms developed and tuned by artificial intelligence and machine learning techniques in order to identify issues with your network based on performance metrics collected from a variety of sources. The ultimate goal of NHP is to identify where problems will occur in your network before they become outages. First, I'm going to cover a high-level architecture of how NHP works. In this diagram, you can see, starting in the lower left, that the UAA platform collects information such as PM stats, alarm information, specific command line output, and topology data from a variety of sources, such as a network element management system, the network elements themselves, or inventory databases. Once UAA has collected this information, it is all ingested by the NHP module, where a number of algorithms analyze the data and attempt to make predictions about where network anomalies may be occurring now or may be occurring in the future. These anomalies are presented to a user via the UAA user interface, or can be presented to OSS, BSS, or ticketing systems via a Swagger API interface. While this algorithm processing takes place fully within a customer premise, data from NHP can also be securely transmitted to the Blue Planet data science team, who continually uses advanced AI/ML techniques and purpose-built systems to refine and improve the algorithms deployed to the NHP customer base. When a new algorithm is developed or an existing algorithm is defined, it can then be pushed back to a customer deployment for immediate use by the solution. This continual loop of improvement assures that the NHP platform always has the most advanced and up-to-date algorithms that provide our customers with the best performance possible. Now, let's take a look at the NHP module itself. First, the NHP dashboard shows a summary of statistics about the use cases deployed and the current performance of those use cases. You can see here that based on the data we currently have in the system, a large number of no-risk scenarios are currently being predicted. This is how users are going to want to see their network most of the time. However, in the alarm status, directly below, you can see that there are a number of ongoing issues with the current use case that is deployed. Next, we'll look at the alarm screen itself. The first thing to point out here is the different columns we have. The first column is the use case we're running in the platform, and the second column is a description of that use case. Here, we're doing line-side risk of loss of service on a Sienna 6500 platform. The third column contains the current status of the deployed use case on the particular facility, and will be recorded as either an ongoing issue, seen in red, or as a predicted issue, seen in blue. Now, if the issue is ongoing, the conditions we're trying to predict are currently occurring, and if the status shows as predicted, then the issue will either show a risk or no risk at all. The fourth column contains the information about the network element. It includes PEC codes and other identifying information. The fifth column contains the time frame of the prediction, and the sixth column here contains the information about the severity of the alert in relation to overall network health. Now we'll take a look at an example of an ongoing event on a facility. On this screen, you can see the alarm information at the top, the device details in the middle, information about the use case that has been deployed in the upper right, and most interestingly, the data that has led NHP to the conclusion it has here in the bottom. If we take this data window and maximize it, it's pretty easy to look at the statistics that have been collected and quickly see that on the last day, there were high correction count seconds on the optical transport unit layer, as well as multiple other errors, including code violations and errored seconds, severely errored seconds, all on the optical data unit layer. These issues, all combined together, have led to a condition that is customer impacting and therefore has been labeled as an ongoing loss of service by Network Health Predictor. Additionally, on this screen, you have the ability to look at the alert history on this tab here, where you can then go back in time and view different alerts that NHP has given for this particular facility. Look at the severities, look at the use cases, where they all came from. And it's pretty easy to see if we go back in time and look at this particular facility. This has been a port that's been pretty unwell for quite a while. Additionally, we also have tabs for service impact, topology, and alarm information, if NHP has the ability to capture that information from inventory or assurance systems, as well as customer information databases as well. One other example in this data set that I'd like to show everybody can be seen on this screen here. Here, the alert history, if we click on this tab, shows a predicted loss of service on July 3rd. On July 6th, it shows as an ongoing event. So you can see that on the 3rd, a prediction was made, and on the 6th, that prediction came true. If we go look at the data, maximize the window, zoom in on the time frame, early July, you can see that the statistics we are collecting on the 3rd, skip forward a couple days, finally to the 6th, you see the high correction count seconds errors, the severely errored seconds, severely errored frame seconds, and errored seconds all on the OTU layer. Network Health Predictor, in this case, successfully took the data that was collected on July 3rd and predicted the outage that occurred on July 6th. Finally, as mentioned in the architecture presentation at the beginning of this video, all of the data is available through the UI I've demonstrated, but also through a Swagger API interface. Here we can run commands to send the output of NHP to a different Blue Planet application, or even a third-party OSS, BSS, or ticketing system. For example, by clicking on the Get Alarm Summary screen, we can run a query that can be copied into a script to show how many risk of loss of service versus no risk of loss of service conditions are occurring. That will conclude this presentation. I hope you've enjoyed seeing Network Health Predictor in action, and if you have any questions, please reach out to your Blue Planet account representative for more details. Thank you.